Hi everyone. Here I'm going to do topic 2, which is significant digits, or so dealing with numbers in science and what do we have to do. So I start with talking about two categories that we have when we work in science. Okay, when we work with science, we have two categories when it comes to numbers. Okay, so one of the category is exact numbers and one of them is approximate numbers. Exact numbers are the one that are coming and are funding, for example, by counting. Okay, so when I count, when I say, for example, I have uh, 3 gifts and I have 2 meters of wrapping paper and I want to divide it between 3 gifts. So the number of gifts so is exact because I can count them 1, 2, 3. Okay, so if something is coming by counting, so they are, so maybe I have to change the color here, they are so they are just exact. If something is coming by definition, for example, when I say in 1 meter I have 100 centimeters, so this is definition. I define that, for example, that's a definition of a square, that each square has 4 sides, so that's exact. Okay, so exact numbers have an infinite number of significant digits, and for this I can just talk about later because we don't know number of significant digits now, so and what is the meaning. But so we can come back later, or I can now tell you this. So when I have something, for example, I say 4 sides, or I have 100 centimeter, or I have, for example, 4 tires in a car, or I have 3 gifts, or I have 3 beakers. Okay, so these are coming by counting or by definition. So I know there is, for example, after there is, for example, 0 0 0 0 0 forever, so infinity number of zeros. Okay, so that's why we say it's infinite number of significant digits. Okay, so you can just hold on to these, and then when we define significant digits and then we come back here, so you can know what do I mean. So it's continuous forever. Okay, so that's why we say infinite. Okay, the second category is approximate numbers. Okay, if you measure something that's just, it comes by error and it's not exact at all. What do I mean? Okay, so look at here. I can have for example a sample, and I can measure mass of the sample using this top loading balance or using this analytical balance. Okay, and I can see it shows me, one of them shows me 2.65 gram, and one of them shows me 2.6524. Okay, so these are that coming by measurement, and I measure them. For example, if I measure length, if I measure mass, if I measure volume. Okay, if I measure something, it's not really exact. It's rounded, it has so uncertainty. Okay, so what do I mean here? Okay, so here, as I said, I have a sample and I measure the mass, and I see one of them is showing me this. Okay, so change the color here. So one of them is showing me this because the top loading balance is showing just 2 digits after decimal. So means after 5, maybe after 5 I have another digit, but it doesn't show me because it's just this device, or it's just this scale. Okay, this scale is designed to show just 2 digits after decimal. Okay, that's a measurement of, so that's the measurement of precision. Okay, so the other one, however, for example, shows me 2.6524. See, it doesn't mean after 5 is 0. No, the other one, which is designed to show me 4 digits after decimal, that's more precise. Okay, it's showing me more digits after decimal. Okay, so that's why we say they are not exact, because it depends on the device. So when I measure something, when I measure mass, when I measure length, when I measure volume, so it depends on the device. Maybe my device is the level of uncertainty for one of the device is just 2 digit after decimal. So it means after 5, I'm not sure what is the digit, but the digit after 5 is just not shown, and the device is rounded to 2 decimal place. It's just showing me 2 decimal place, so it will rounding. So it will round the number. And the second one shows me, so the uncertainty level is 10,000 place. So it means 4 digit after decimal. Okay, so look at here. So again, after four here, it doesn't mean it is zero. No, after 4, this device is rounded to 4 digits after decimal. Okay, as you can see, the digit after 5 is 2. Okay, and this device is the first device is rounding it. So maybe the digit after 5 is 0, maybe 1, maybe 2, maybe 3, maybe 4, and it's rounding it. Or maybe it's 2 6. I'm talking about this one. Maybe it's 2 6, 2.6, 4 6, 2.6, 4 5, 2.6, 4 7, 4 8, 4 9, and it's rounding it. Okay, so it's rounding that. So I'm talking about this digit here, that is at the last digit, which is 5. Okay, so again, when I talk about numbers, if numbers are coming by counting, if they are coming by definition, they are exact, and they have infinite number of significant digits, which we will see the definition of significant digit later. But if I measure something, it really depends on the device and how accurate is my device. So how precise is my device, and how it shows the digit. Okay, so one of them, if it shows 2 digit after decimal, so it is rounded to 2 digit after decimal. So it doesn't mean after second digit after the decimal. So for this one, it doesn't mean after 5 is 0, maybe no, maybe 0, maybe 1, maybe 2, maybe 3, maybe 4, and it's rounding it. Okay, and the other one is showing 4 digit after decimal, because that device is defined that way. Okay, so of course it depends on the device, and it depends on the uncertainty of the device, so I can see different digits. Okay, so we call this precision. The decimal places of the last significant digit of a measured quantity, okay, that indicates the precision. So how precise is the device. Okay, so if I want to give you more definition and make it more clear, precision is the degree of if you can reproduce the series of measurement. Okay, so if you measure several times, okay, and you see that the measurement values are close to each other, you can say that your measurement is precise, because the precision is low, they are close to each other. Okay, so precision shows how the measured values are close to each other. That's precision. Okay, so you will see this in the next math course as deviation. So we say the deviation so is low because they are very close to each other. Okay, so we will talk about deviation later in next math. Okay, so precision, the first device is precise to 2 digit after decimal, and the second one is precise to 4 digit after decimal. Okay, so it means if you do several measurements, so they can be close to each other, just for the first one to 2 digit after decimal, so for the second one to 4 digit after decimal. How about accuracy? Accuracy shows how your measured value is close to the true value. So you are not comparing values that you measured with each other. You are comparing the values with the exact, sorry, I say exact. No, with the accurate or actual value. For example, I say on the lab menu says on the lab manual, I said menu, sorry. on the lab manual says that you have to, when you measure this, it must be this amount. Okay, that's accurate value. Okay, so that's a true value, that's actual value. Okay, so how the measured value is close to actual value, we say this is accuracy. Accuracy is the degree how the measured value is close to the true value. Okay, so when we talk about accuracy, we have to consider all the digits because we want to know what is the number and if it is close to the actual value. Okay, so the actual value comes from your teacher, comes from lab manual, comes from the book. So the book says it has to be this. Or many times when you are working in the lab, you don't have um, you don't have the true value because you don't know, you are producing something and you are measuring it several times. So precision is important because you are just seeing how the values are close to each other. Accuracy is how the value is close to the actual value, but sometimes maybe we don't have access to actual value. If I want to show you with pictures here, I can say these yellow dots are measured value and the red one is actual value. For the first one, they are close to actual value, but they are not close to each other. So I have high accuracy because accuracy shows how the measured value are close to the true value. But low precision because they are not close to each other. The second one, they are close to each other, high precision, but they are far from the actual value, so low accuracy. Here you have close to each other and close to actual value, so you have high accuracy and high precision, which is the best experiment that you can have. Okay, so as I said here, precision is how the measured values are close to each other. So if you use this device and measure it several times, it shows you 2 digits after decimal, but maybe once 5, maybe once 4. So it depends of just the depends on many things. So maybe you make error, maybe there are some errors in the environment, so that causing you to make error and many things. So maybe some errors are avoidable, some of them are not. Maybe it depends on the temperature, those things. Okay, if you use this one, it shows you 4 digits after decimal, but maybe they are a little bit different with each other, so we can say how they are precise. If they are close to each other, the precision is high. Okay, so here, before I go to the lesson, I like to define significant digits. As I said, significant digits are all the digits in the so all the you have to consider many things, but all the digits that you see in the answer, in the number, maybe they are significant digits, yes, maybe they are not, but we have to consider them because we want to know how accurate is our answer. So let me tell you these rules about significant digits. If your number doesn't have any decimal, if there is no decimal, you see no zero, so you have to count all of them. So you say you have 7 significant digits or significant figures. Okay, so significant figures, all the digits in the number, significant figure we call them. Okay, so numbers rather than zero, they are all significant. I have to count them all. Okay, how about if I have zero? Zero is problem. If I have zero and zeros are between non-zero digits, I count them. See, here zeros are between non-zero digits. I count them. Okay. If I have zero and they are at the end of the number, for example, if I change my number to scientific notation, I don't see them. They are placeholder. They are just placeholder. They are not significant. So if you change your number to scientific notation and you don't see those numbers, those digits, they are not significant. You don't need to count them. Okay, so here I count them all in one. I count them one in two. I don't count this. The next, if I have decimal, and I don't see any zero, I count them all. If I see zero between, I count them all. Between non-zero digits, I count them all. If I see zero before the first non-zero digit, so I have zero before first non-zero digit, I don't need to count them again, because again they are removed if I go to significant digit. Sorry, if I go to scientific notation. Okay, if I go to scientific notation, I don't need to mention them. Okay, so I have to start counting significant digits from non-zero. So I have to start from here and I have to stop until end. I have to go to end. Okay, so what should I do with these two? I don't count them, because if I write in scientific notation, look at here, so I don't see them. Okay, how about if I have zero after decimal? How about that? Okay, I mean this. Do I have to count them? Yes, because if they are not important, I don't need to mention them. My answer here is 5. So I can just say 5. Mathematically, it's 5. For my calculator, it's 5. But when I say 5.000 here, I say 3 zeros after 5, after decimal, because I want to emphasize, I am sure this digit is 0. I am sure this digit is 0. And I am sure this digit is 0. I am sure about them. Okay? Otherwise, I don't need to say. See, they won't be listed if they are not important. So they are important, I have to count them. So if you have no decimal, start from the first non-zero digit. Of course, you don't have any zero before your numbers if you have no decimal, and just go to the last non-zero digit. Okay, you don't need to count zeros at the end if you don't have decimal. If you have decimal, again you start from the first non-zero digit, means you have to pass all the zeros, and start from the first non-zero digit, but you have to count until end, means if you have zero after decimal, you have to count them, because if they are not important, you don't mention them. Okay, zeros which are located for decimal points, they are not significant. As I said, here we are talking about these zeros. Okay, these zeros here, all digits including zero, all other digits including zeros, all other zeros, I mean zeros who are between non-zero digits, or zeros who are after decimal, I have to count them. Okay, so let's do this here. What is the example here? What is the answer? Okay, so 1 second. Yeah, uh, yeah. Okay, so here, how many significant digits I have? 4. Here 5, and here 7. How many here? 4. I know I have 0, but zeros are between non-zero digits, so I count them. So 5, 4, 5. Okay, so between non-zero digits and after decimal, I count them. See, these are between non-zero digits. I need to count them. I cannot even remove them. Okay, so I need to count them. And after decimal, I don't need to mention them if they are not important. So when I mention them, I have to count them. Here, I can say 3, but When I have 3.000 means I am sure those digits are 0, so I have to mention them. Zeros here, for this, the last part, I have zeros which are not important. So these, because it's no decimal at the end, zeros at the end, so I have 3, or this one and these 3 here. Okay, these two are just here that the number looks good. That's it. I mean these here. The number looks good. So I have to say to look good. Okay, just this is just agreement. If we don't have any digit before decimal, we put 0. Okay, so how many you have here? 2. And how many you have here? 1. You don't count this. You don't count zeros at the end of number when you don't have decimal. You don't count zeros before if before the first non-digit if you have decimal. Okay, so you don't count this. Now, in decimal numbers, zeros are sometimes used to locate the decimal point, so they are not significant. So as I said, okay, so here how many? 4. Here how many? 2. Okay, because I can say 2.3 times 100. I don't need to, I can remove that 0 and I can write it as scientific notation. How about this? Just 1. Okay, how about this? 2. I don't need to mention 0 after decimal. If I mention means it's important. Otherwise I say just 4. How about this? 3. Okay, so you don't count these, you do not count this, you don't count this. The rest you count. Non-zero digits you count. Zeros between non-zero digits you count. Zeros after decimal you count. The rest, which are zeros at the end or zeros before non-zero digits in decimal, you don't count them. Exact number have infinite significant digits. Infinite significant digits. As I said at the beginning. At the beginning, I talked about exact numbers. I said this. What do I mean? So when I have 4 gifts, I am sure it's exactly 4. Okay, so I am sure I have infinity number of zeros after here. So I have infinity number of significant digits because I am sure about them. I am sure. Okay, so I put a dot and after decimal, I count them all. So I don't need to mention them if they are not important for me. So when I mention they are important for me. So if I have exact numbers and I am sure that's exactly 4, so after I can put decimal and I can put infinity number of zeros and then I can say infinity significant digit. Okay? Approximate numbers, however, they have certain significant digits and you have to really look at them and you have to follow all the rules and you can count them. Okay, so I have to mention some rules here. Just 1 second for my coffee. Okay, some rules to summarize. Significant digits only apply to measured quantities. So if it is not measured, if they are exact, they have infinity number of significant digits, so I even don't consider them. See, here I said infinity, so I don't consider them because it's infinity number, so I don't consider. If I have exact number, I don't consider in rounding or in anything that has that is related to significant digit. The first, okay, here. Okay, oops. Measure. Exact number have an infinite number of significant digits. I show it. Okay, So I do not count, I do not even consider them because it's infinity. All non-zero digits have to be counted, as I said. Okay, so all of them. Begin counting at the first non-zero digit and stop at the last digit recorded. Stop counting at the last digit. Okay, means if you don't have decimal and you see zeros at the end, you don't need to count them. Okay, so here is the just summary of what I said. So here and here tells you that you don't need to count zeros for decimal numbers. You don't need to count those zeros that are after decimal and before the first non-zero digit, and for non-decimal you don't need to count zeros at the end. Why? Because it says begin from the first non-zero digit and then stop at the last one recorded. Okay, so zeros when counting significant digits. Zeros are problem. Okay, so I want to emphasize on them more. Zeros between non-zero digits are counted, so you have to count them if they are not, if they are between non-zero digits. Zeros after decimal, you have to count them. As I said, 8.200 is just 8.2 for my calculator, for me. When I mention these, I don't need to mention them. When I mention them, it's important. So after decimal, I count them. Zeros after decimal and before a non-zero digit are not counted. Okay, so you do not count them. Okay, so maybe I change the color for this and no, not this. So if it is after decimal and before, because they are just fixing the position of decimal. If you change your number to significant scientific notation, you don't see them. See, it's 4.5 multiple 10 power 10 power minus 4. Okay, yeah. Okay, so if I write my number this way, then I say, okay, so I just have two significant digits because I look at here. So you can change your number to scientific notation and then see how many significant digits you have. Okay, zeros after a number and before a decimal, so means these zeros are ambiguous, means they are not clear. Okay, so it depends on many things, but for this course, okay, for this course, we say we don't count them, we don't count those zeros. Okay, if there are no numbers after decimal, then we treat the zeros as placeholders and they are not significant. If there are zeros after the decimal, then since those zeros are not placeholder, they are significant. See, here we mean, here it's repeating what I said. So if I have decimal, so this one means, for example, if I have decimal, so here and I have this 4 5. Okay, so if there are no number after decimal, then we treat the zeros as placeholders and they are not significant. Okay, if there are zeros after decimal, then since those zeros are not placeholders, so I mean this, for example, 45.000, so I have to count them. Okay, so as I said, sometimes when we have a number and zeros at the end, so we say it's not clear, ambiguous. So for this course, we don't count them. Okay, so as I said many times in the rules. Okay, so a bar above a zero indicates that it is significant digit. If I want to mention a zero is significant and you have to count it, I put a bar top of it. Okay, see, if I have 40, this is one significant digit. If I have this is two significant digits because I have a bar top of it. Or if I have this, also two significant digits because you see decimal. Okay, so you count them. But remember, don't do this because this is three significant digits. So, yeah, here I can, yes, I can change all of them to lowercase. Yeah, I can follow this. Yeah. Okay. Now we can talk about this. So here, how many significant digits each one has? Okay. So this one 3, this one 2, this one 3. Okay. Let me see. Yeah. This one 2, this one 5, because I need to count this because this is after decimal, so I have to count it. When I mention it, it's important. The next one 3, the next one, see, these zeros are between, so I have to count them. Okay, I have to count these. They are between, so I count them. Okay, so it's 7. The next one, I need to count this, and this 0 is also between two non-zero digits, between two significant digits, so I have to count them. So therefore I have 3, but I don't count this, it's after. Okay, how about this? Zeros are between, so I have to count them. So two zeros are between, so I count them, so it is 5. How about this? I do not count this. The first one is here just to look good, and I need to count this because two blue zeros, which I highlighted in blue, they are here because they are important. Otherwise, I don't need to mention them. Okay, so 3. And how about here 1? And how about here 1? Okay. Now we want to talk about how to round it. So I continue this in the next lesson. Okay. So rules. If you see decimal, just decimal number, look at this. If you see decimal number, forget all the zeros and reach to this digit. Reach to the first non-zero digit. Then start counting until end. Okay? So I pass the green one, I pass the yellow one, I start from 1, 2, 3, I count them. If anything else in decimal numbers, I count them. Non-zero digits, I count them. Zeros between non-zero digits, I count them. Zeros at the end, I count them. Because I don't need to mention them. If I mention them, they are important. If there is no decimal, do I have 0 before? No. Of course no, because it doesn't make any sense. When I have no decimal, I don't start from 0. Okay? So I start from the first non-zero digit and I just stop until non-zero digits are done. I don't count zeros at the end. Okay, so they are yeah, these are not counted. So here the yellow ones are not counted. Okay, when I have decimal before first non-zero digit, and when I don't have decimal after the last digit, those zeros are not counted. Anything else is counted. Any other numbers are counted. So non-zero digit counted. Zeros between, so zeros is just, zeros are important problem. Okay, so zeros after decimal and zeros between non-zero are counted, which are coming in E is zero after decimal, G are zeros between non-zero digits, H are zeros with bar and between non-zero digits, and I zero between non-zero digits. J is zeros after decimal, so I count them. The last one, which is L and J and H, they have zeros that you do not count them, which are in decimal number before we start the first non-zero digit, or in non-decimal number just at the end of the number. Remember, you can change your number to significant notation, scientific notation, and then say they are not, which are significant digits and which are not, and which one you have to count. Thank you. I continue after.